Okay guys, what we're going to do first here, this is one of two videos. Firstly, I'd like to just revisit all the different ways of solving quadratic equations that we've dealt with. The first one, of course, have a look at this one here. Think about what method you would consider appropriate. We've got a is equal to 1, we have nice numbers here. Have a look at this one here. Once again, pretty nice numbers. We have an 11 and an 8. Yeah, there's not a lot of difference between those two. But over here, I look at this and I think, oh my goodness. Think of what your first instinct is to work with that one. So this is what I see when I look at those. I'm going to ask myself these questions. Firstly, will it factor? So I'm looking here at two numbers that multiply and give negative 14, add to give negative 5. Yes, absolutely. We definitely have two numbers there. We have negative 7 and plus 2. So we can definitely factor that. And that's going to be always the quickest and easiest if we can. Here though, we're having a look at two numbers. Think about this for a sec. Multiply to give 11. What are the factors of 11? It's 11 and 1. Are they in any shape or form ever going to get you 8? No. Okay, so it won't factor. But if we have a look at that b value, that's a nice b. That's a nice negative 8. So you may think here of completing the square. Okay, that's a nice easy one to halve the square. Have a look over here. We have yucky numbers. First of all, we notice that a is not equal to 1. That makes the factoring harder even if we're going to use factoring. And there's decimals and horrible things. And so the first thing you think about there is, oh my gosh, I'm going to delve in and use technology here. So I want you to start to get used to thinking about when you'll use factoring and how you will identify whether an equation is suitable for factoring. When might you use completing the square? If it doesn't factor and you've got a nice b that's nice and easy to halve, that's a pretty easy completing the square. Here, what makes it awful is these decimals and the coefficient there. And even if you had a question like this perhaps, 3a squared minus 9a plus 11 equals 0. Even that, you might have a look at this and say, okay, the numbers are okay, but I've got a is bigger than 1, so even factoring is a little bit more challenging. And even completing the square, because we'd have to go through and divide everything by 3 first. So even the first two methods, could be challenging. So even ones like that where a is not equal to 1, we often think of going to our graphing calculator and getting our x-intercepts, our zeros. I'm throwing in an alternative route today. Here's another way we can consider these not so nice quadratic equations. This is a great one using technology, we're all comfortable with that. There's another algebraic way and it's called the quadratic formula. But it comes directly from your ability to complete the square. So we're going to have a look at where this quadratic formula comes from. Okay, so I'm going to start off in standard form. And I've got ax squared plus bx plus c, and we've got it equaling 0. So we're ready to factor if we so need. The first thing I say is, I don't like completing the square with this a, so I'm going to go and divide everything through by a. So when I do that, I've got x squared plus b over ax plus c over a. 0 divided by d, that doesn't change. We've still got 0. Okay, so now I'm just going to set up my structure. I like to have this. I'm going to be looking at this part here, so I'm just going to separate this. So I've got x squared plus b over ax, and I'm going to have something here. Let me just put my c over a, minus something there, plus my c over a equals 0. So let's just have a little think about this. And you might want to do this over the side. Think about completing the square. What we want to do is halve this number, square it, and that's what's going to be there. So think about that. What is a half times b over a? We're going to have b over 2a. So now we've got to square that. So we've got b over 2a squared. So we're going to have here squared over 4a squared. Put the fraction bar there. But now I've added my b squared minus 4a squared, so now I've got to subtract that again. B squared over 4a squared. Okay, so the next thing, of course, is to break this down. We've recognised that's a perfect square, so let's write it as its perfect square. The question is, we've got x plus what that's going to go in here? Well, we can get it from two places. We can get a half of this value, which was the b over 2a, or the square root of that, which was b over 2a. So we've got our b over 2a there. And coming over here, we've got our, oops, that's a minus b squared over 4a squared plus c over a equals 0. Let's go and neaten this part up first. That was the next part. Doing exactly the same as we did with numbers. So let's go over here. I've got my highest common factor of 4a squared. So I'm going to do this. I've got x plus b over 2a squared minus b squared over 4a squared. Now think about this. What do I have to multiply a by to make 4a squared? I've got to multiply it by 4a, don't I? So I've got 4a on the bottom, and I've got to multiply the top by 4a. So 4a times c is 4ac. Okay, two more things to do. We're going to take the square root. We've got to take this over first. So let's take these two things over to the other side. We've got x plus b over 2a squared equals b squared over 4a squared. That'll become positive over there. This will become negative. Minus 4ac over 4a squared. That should be a squared there. 4a squared. Okay, now we can take our square root. So we have got x plus b over 2a square rooted. Now remember, we've got our plus and minus. B squared minus 4ac all over. I'm just going to combine these two fractions. 4a squared. Okay, I'm going to just go over to the next page and put that back up again. So we have, once again, x plus b over 2a was equal to, we have plus or minus the square root of b squared minus 4ac over 4a squared. Okay, just about there. Now let's just subtract this from both sides. I've got x equals minus b over 2a plus or minus b squared minus 4ac over 4a squared. 4a squared. So what we've now done, we have solved the equation. It is solved. We're done. We are just going to neaten up this formula a little bit now and have a look at the different ways that you may see it written. Okay. So the first bit I want to draw your attention to is this. 2a, 4a squared. You might notice the relationship between those. This one is 2a squared. So just going back to some radical work, if you had a fraction, a over b, you can separate that, can't you? Like that. So we're going to apply that over here. So I've still got my x equals minus b over 2a, plus or minus square root of b squared minus 4ac over the square root of 4a squared. And if I just address that, I now have minus b over 2a plus or minus square root of b squared minus 4ac over 2a. So there's one way you may see the quadratic formula. Given that you've got a quadratic in standard form and you are solving, finding the zeros, the solution, the zeros, can be given by this. And this has just come from completing the square. The other way you may see it is if I just combine these two fractions, you may see this. X equals minus b plus or minus square root of b squared minus 4ac all over 2a. This is the way you'll see in an IB formula booklet but either way it means exactly the same thing. The next video I'm going to do is about